Welcome. We have the question number one. Give notations, representations of the following component of formal languages. So, alphabet. It is a finite set of symbols and denoted by submission. For example, submission is equals to 0, comma 1. A string. So, string, it is a finite sequence of symbols over the submission and denoted by W or omega. Empty string. It is the string with zero symbols and zero length. It is denoted by epsilon, length of the string. It is the number of symbols composing the string and denoted by omega under the uh, modulus. Prefixes. These are all the possible leading symbols and substrings. For example, for a string, omega is equals to TOC. Suffixes. These are the possible tailing symbol substrings. For example, for strings, omega is equals to TOC. Now, language, notation, LMN, usually uppercase letters, description. It represents a set of strings over the alphabet. A submission, for example, language is equals to ABC, where all the strings are formed by using symbols from a submission. Operators on language, such as union, intersection, concatenation. These operators are used to perform various operations on languages. For example, union combines two languages into one. Intersection finds common between the strings and between the two languages, and concatenation generates strings by concatenating one string from language L with another language M. So now B part of the question number one, finite automata is the mathematical. So define the finite automata and acceptance by string by finite automata. So the finite automata is a mathematical model of the system consisting of set of states and transitions A. A finite automata is a five-tuple system. So the acceptance of a string by FA can be defined as the string omega is said to be accepted if it's for some final state. So the finite automata is consist of five tuples. So now the C part of the question number one is difference between NFA and DFA. So NFA stands for non-deterministic finite automation and DFA stands for deterministic finite automation. So there may exist more than one transition for each input symbol in NFA, and in DFA there may exist exactly one transition for each input symbol. It permits epsilon transition. It will not allow epsilon transitions. So in NFA table may contains multiple defined entities, and in DFA table contains only single entities. So true and false in which is the D part of the question number one is uh, if L is the language accepted by NFA, then L is also accepted by DFA. So this statement is true. For every NFA, there exists an equivalent DFA that simulates the behavior of NFA. That is also true. In NFA to DFA conversion for N state NFA, there exists at most two N state in DFA. So that is false. So the question number two is regular sets or regular languages and regular expressions. So what are the regular set, regular languages, and what are the valid operations used in regular expressions? So the language recognized by finite automata are called regular sets or regular languages. It is possible to write regular sets in simple algebraic manner using the following operations called regular expressions. So concatenation is denoted by dot operator, union is denoted by plus, and clean closure is denoted by star operator. So complete the table with correct regular expression. So here are the regular language given, and corresponding to that, the correct regular expressions are given here. So important languages and regular expressions over 0, 1. So some examples are set of all strings of 0 plus 1 star or 0 1 star, set of all strings ending in double zero, 0 plus 1